Hello and welcome to Eco Show. I'm Henry, and this is Eco Show, a show about happenings in ecology, the environment, and things related to that. I usually talk about a ecological thing of the week. That could be an animal, it could be an insect, it could be just a thing in nature, as it is this week. So I usually highlight something at the start of the show. Then I talk about a recent research paper and then the most recent news in the world of ecology and the environment. So let's hop into it this week. Thank you for being here. Thank you for listening and going along with this. Our thing of the week this week is our clouds. So I'm going to go and do an overview of the different types of clouds because I was interested in that this week and I wanted to look that up. So now I'm forcing you to look at it as well. Okay, so clouds form when air rises from the earth with water vapor. And so that water is in its gas form. And then moisture condenses, and as air continues to pull up that water vapor in the air, more cloud is created. We're going to go through the main cloud types so that you can point these out. And they stuck in my head. Usually names don't stick in my head too well, but they have this week. And the thing I like about clouds, as in sort of ecosystem, earth system thing to learn about, is that even if you're in a city, no matter where you are, you can always look up and you can try and identify some clouds. So we're going to go through the six main cloud types, but these are broken down into even more specific types and things like that. So you can really go wild with that if you want to explore something. But these are some of the main cloud types. So the first one we're talking about are cumulus clouds. And these are just the usual clouds that you've probably drawn tons of times. And cumulus means heaped. So to remember these names, I'll try some different things to remember what the names mean. So cumulus is kind of like accumulate. So it's just a heaped cloud. They usually have flat bases and look like cotton, these cumulus clouds. They may appear alone, in lines, or in clusters, and they can be composed of ice crystals, water droplets, a mixture of those, and they usually mean fine weather. So that's our usual cloud is the cumulus cloud. So next time you see a normal looking cloud, you can try and remember that name. Our next major type of cloud is called cumulonimbus. And cumulo, like we just found in the last cloud type, means heaped, and nimbus means rainstorm, which I thought was interesting because I was thinking about the Nimbus 2000, or maybe it was 3000, whichever one it is that Harry Potter gets, and I wondered why it would be called Rainstorm 3000. But anyways, so cumulonimbus clouds are pretty much when cumulus clouds just get larger. So there continues to be cloud getting produced up and up and up, and it extends high up into the atmosphere. And as we can see in this photo here, you can see the rain coming down below it. So you can imagine that if there's been more and more cloud produced up there, that means there's more and more water, moisture that's being held up in the cloud, and a higher likelihood that water will start to fall out of the cloud. Okay, our next type of cloud is called a cirrus cloud. And the way I remembered this, and sort of sticking with the Harry Potter themed, is thinking about Sirius Black, which is a big dog. Well, it's a guy, but he can turn into a dog. And cirrus means curl, or it means hair. So when you see these clouds and they look sort of curly, they look very wispy, you can think that it looks like kind of hair like a dog, like Sirius Black. And so cirrus is our, it's not Sirius, it's cirrus, Cirrus. And these clouds are typically very high up in the atmosphere. They're wispy, and these are made of ice crystals. Generally, they're indicating good weather, but you can sometimes see the way the curls are pointing can indicate where an incoming front is coming from. So here's some nice looking cirrus clouds. Our next main type, and there are so many different sub-classifications, and there are other types of clouds, but this is the last main type we'll talk about this week, so hopefully we can remember these. And our last one is called a stratus cloud. And stratus means layered. These clouds are that sort of low, continuous cloud where if you've ever been up in the mountains someplace and you look out and it's just looks like a whole blanket of cloud. Those are stratus clouds. They are the same as fog, and they may bring some light rain, but they actually usually don't mean that there's going to be too much bad weather. That's our last one. So stratus, the way that we can remember the name is, I would think stratified, but you don't really, when you look at this type of cloud, that stratified doesn't particularly come to mind. So stratus rhymes with, what's a US word? Stratus rhymes with, I can't think of anything. So we may just have to try and memorize this one, stratus clouds. So go and quiz yourself outside tomorrow with some clouds, and if you can't identify it, look it up. Start getting your cloud understanding down. And even though we have, and what a fun game would be looking at the clouds and looking up what they indicate, and then checking that with your weather forecast and then what the weather reality is. It's a fun thing to understand. Even if we have accurate weather forecasts, it's always fun to build some new skills. Okay, and some interesting things about clouds are that they have a big environmental impact. Generally, they cool the earth, and they do this by reflecting light. But clouds which are high in the atmosphere and generally are made up of ice crystals are typically transparent to light, and they can let light through, and they can actually warm the planet by letting light through and then insulating heat inside. And this is an interesting thing to note because there's a big climate impact from the aviation industry, from emissions and things like that, but actually a big impact on climate that aviation makes is via the clouds that are left over by planes. Sometimes up in the air you can see, and it looks like there's clouds coming off the back of them. And what's happening is that the plane is moving through a patch of weather where it's cold and humid, and the water vapor, so humid air means that it has a lot of water in the air. The water vapor in that air condenses onto soot from the plane that's being left out by the engine. And so that's where it may not be totally consistent across the sky because the plane may be moving through different patches of water vapor up in the higher atmosphere. But flight paths can be designed to avoid these patches of weather and to make, I think it was up to 60% of a difference in the impact of these clouds can be done by just changing 2% of flights. So they just need to change flights around a little bit every once in a while to avoid these patches, and they can avoid causing these clouds to come out and this condensation to come from the back of the plane, which does warm the earth because, like we said, those high atmosphere clouds let light through, but then they conserve heat around the earth, kind of making it like a blanket. Okay, so that's a little overview of clouds for us. Now we're talking about research. So our research for this week is titled Quantitative Fatty Acid Signature Analysis Reveals a High Level of Dietary Specialization in Killer Whales Across the North Atlantic, which gives away what this is about, but it's so many big words after one another that even I don't. You have to sort of dwell on it for a minute. And this is by Anais Remeli and Rune Dietz. This was published in the Journal of Animal Ecology. So this is research on orca diet. And you may be thinking, why do we need to know what the orcas are eating? But it's important to understand what orcas are eating because they're apex predators, which means they're the top of the food chain. So depending on what an orca eats, that's going to impact the food chain downwards, and the bottom of the food chain is in the reverse way going to impact orca populations. So it goes both ways, that it's interesting to understand them for conservation of not only themselves but other things that they'll be eating and impacting in the food web, which just is food web just means the interconnections of things eating each other, from little plankton that are small to big things like orcas that are being eaten. Also, as with all research now, it all has to relate to climate change. So particularly sometimes these smaller populations can be impacted by changes in the ocean and climate change. So it's interesting to know. But how would you look at their diet? So last week we talked about looking at hammerhead sharks, or we talked about some research that is looking at hammerhead sharks and trying to understand where they are subsisting mostly. And for that research, they were looking at mercury. And for this research, what used to be done is observations in nature of what orca were eating, but this is pretty hard to do, tracking orcas around. But for this, they looked at the fatty acids in the blubber or in the fat of orcas, because these remain generally unchanged in prey from their prey. So prey will have fat in them that gets eaten by orcas, and the components of that fat will be, or the fatty acids will be generally unchanged. And they also created a model in this research that modeled how the fatty acids will be changed when they get digested by the orca. And I'm just going to read a definition of fatty acid. I should have put that in there. Yeah, so fatty acids are just the broken up pieces of fat from prey that has been eaten. Okay, and let's see. Yep, so this stays in their blubber so they can look at the blubber from orcas and pretty much pinpoint what it is that they've been eating. And how did they get these blubber samples? Well, they were able to get it from samples from orca, which were traditionally harvested in Greenland and the Faroe Islands, which are in the Atlantic. The Faroe Islands is, I believe, between Iceland and Europe. I'll put up an image of where it's at. So they got some samples from that, and they also had this. They used a crossbow and darts, so it sounded like they were hollow darts that they shot at the orcas that they could then pull out a sample of blubber from. So then they had lots of references for the approval that they had to get to do that. So they got their they got their animal ethics approval to crossbow some orcas. And here we have a map showing the diversity of prey for different orcas. So orcas have generally been classified a little bit more simplistically in terms of what it is they're eating. And we can see that over on the left side of this map, which is eastern Canada, we can see the green are porpoises and whales and things. The red colors are types of fish, and the blue colors are seals. So we see over around Canada, I didn't realize how many whales and things get eaten by orcas, which for some reason I had in my head that whales and things don't eat other whales. So that was kind of a cool thing to see. And they're eating a lot of whales around eastern Canada, so it definitely makes you curious about why. I'm pretty sure there have been no reported human attacks by orcas, but they're eating mammals, so good thing to be aware of. And around Greenland, there's more seals being consumed by orcas. And then over on the Atlantic side, we have a bit higher proportion of fish being eaten. And by understanding what is being eaten by these orcas, we can understand as these species may start to change in their populations. You can then start to model what may happen to orcas and vice versa. If orca populations get bigger or smaller, what might happen to these populations of animals. Let's move on to our news for this week. This week, our first piece of news is that Greenpeace won a lawsuit. They had a lawsuit thrown out technically and were awarded $1 million. So what had happened was that Greenpeace led a campaign against some logging practices, and a forestry company then accused Greenpeace of making false claims about its logging. Greenpeace said what we said was actually true, and this went to court. The judge ended up siding with Greenpeace, saying essentially that what Greenpeace was saying was true. And the judge also found this forestry company of filing a SLAP lawsuit, which is a strategic lawsuit against public participation, which basically means a lawsuit that is filed just to prevent action being taken on something. And they are generally used to stifle some efforts against different companies that may be having bad practices. So because this was considered a slap lawsuit by the judge, that gave Greenpeace $1 million. So it was kind of setting a little bit of a precedent in this case that you may not be able to get away with suing another company just in order to get them to not to stop them from critiquing what you're doing, essentially. Okay. Our next news article is that renewables are going to be the top energy source very soon. The International Energy Agency, or IEA, has said that renewables will be the top electricity in 3 years. But they also said that new storage capacity is needed in order to accomplish this. So renewables are on the way, but as we've been talking about in different weeks, renewables are tricky because they are requiring minerals and things like that in order to produce them. So they can be tricky in their own ways. Our next piece of news is that a roadmap for plastic waste was released by the UN, and this roadmap would reduce plastic pollution by 80% by 2040. Key actions recommended include banning or taxing single-use plastics, promoting reusable alternatives, and improving recycling infrastructure. Because even though a lot of plastic is presented as being recyclable, a lot of it ends up in landfills anyhow. Some key findings from this report is that plastic pollution is a major environmental problem with many negative impacts. They also had a key finding that current efforts to reduce plastic pollution are not nearly enough. The last major one of the key findings was that significant changes must be made to reduce plastic pollution by 80% by 2040. So these are all sound like pretty straightforward things, but it's important when they are being acknowledged by that mainstream group, which is the UN, and can start to bring more momentum into necessary changes. So it's good, particularly that when they note that current efforts are not nearly enough. You like to hear that. And so it's kind of positive that they're acknowledging that it's a bad thing. And our last news article of today is that there has been a successful recovery of United States oyster populations. Oysters have been knocked down over the years by poor fishing practices and pollution. So some of those bad fishing practices for getting oysters include trawling. So you just scrape the bottom of wherever those oysters are growing, which damages the habitat that they need because they need their own reefs. Another issue includes pollution from waterways. So restoration has occurred by rebuilding reefs, making sort of artificial reefs with shells and concrete. they found that restored oyster reefs have a 21-fold increase in population compared to control reefs, or reefs that populations of oysters where nothing was done to improve their habitat over about 8 years, I believe. So that's a really big. So it took some time to see it, but now that it's coming along, it can be done successfully. This also has add-on effects of improved habitat for fish and nutrient cycling. So that's taking some nasty things out of the water as it's moving out to sea or as it's around the shoreline. And that is all the news that we have for this week. So I think this was a relatively snappy one. I hope you've had a good week so far and that you're having a good weekend or whenever you're listening to it. And we'll catch you next time. Thank you. Bye-bye.